Okay, so we're going to end the first day by talking about heat balance. Okay, and so remember how we mentioned there's several methods of heat transfer? Well, we're going to talk about those today. And so your body temperature is based on basically the sum of how much heat you're gaining, how much heat you're losing. Okay, and there's 5 processes: metabolism, evaporation, radiation, conduction, and convection. Okay, metabolism will always increase your body temperature. Evaporation will always lower your body temperature. And then radiation, conduction, and convection can either increase or decrease your body temperature depending on what's going down or what's going on, which way the gradient is. Okay, so ignore this because you're probably watching this by yourself. So what are each of these? So metabolism, in order to do anything, well, we're just a series of chemical reactions, and those chemical reactions release heat. Okay, much of what those chemical reactions release is heat. The rest we can use for work. And so as a result, like for example, when you go exercise, you get hot. Why? Because there's more chemical reactions going on. Okay, as far as I know, there's no way to make a cold, have a chemical reaction and cool you down. Then we've got radiation. And so radiation is when heat waves, not heat waves, but electromagnetic waves are either emitted, given off, or absorbed. Emitted and given off mean the same thing. Conduction is when you touch something and either you gain the heat or you lose heat. Okay, it depends on the gradients. We've got convection, and so convection is heat movement as something moves through a flowing fluid. The atmosphere is a fluid, okay? The swimming pool is a fluid. And so you're always experiencing convection, and the more movement there is, the more heat transfer there is. However, it's very different between air and water. Air has very low convective properties. Water has very high convective properties. The example I use, if I told you you have to do one of 2 things, okay, it's a must. You either have to put your hand in boiling water, which is 212 degrees Fahrenheit, or you have to put your arm inside an oven that's set to 350 degrees. Which one are you going to do? Okay, and the answer is you're going to probably put your arm inside the oven. You're not touching anything, okay? Because yes, it will be hot, but you're not going to cause the damage that you would if you put your hand in boiling water, okay? You would be able to experience the one for several seconds, whereas the other one, you put your hand in boiling water and it's game over. Then you've got evaporation. And so this is when we take a fluid and convert it into a gas. This only causes heat loss. This is how we lose most of our heat. Okay. The problem is, think about when you sweat. What do we often do with our sweat? And the answer is, oftentimes we just wipe it off, right? When you wipe off sweat, and I understand why we do this, you're actually preventing evaporation from occurring, and then you're not going to sweat as effectively, or you're not going to cool off as effectively. So I want you to think for a minute. Let's just say you go for a run, and it's 40 degrees Celsius, 104 degrees Fahrenheit. So how will each of these affect your body temperature? Okay, and I just want you to think in terms of metabolism will cause increase, radiation will cause decrease, convection will cause decrease, whatever it is. So the answer is metabolism is going to increase your body heat, always does. Radiation is going to increase your body heat because in this case, the environment is hotter than your body temperature, so you're actually going to be absorbing heat from the environment. Conduction, you're going to gain a little bit of heat, likely as your shoes touch the ground when you're running, that sort of thing. Convection, you're running through a hot fluid, okay, but because it's a hot fluid and not a hot liquid, you're not going to be gaining a ton of heat. And then with evaporation, you're going to be losing heat because evaporation always causes you to lose heat. So, along those lines, if external or ambient temperature exceeds body temperature, the only way you can cool yourself is evaporation. The problem is, especially in the Midwest, is that humidity plays a huge role in this. Remember how the amount of what relative humidity is how much water is in the air relative to what the atmosphere can actually hold. Now, if you're from the West Coast, which is the best coast, in the summer or just generally, humidity is very low. Even in Oregon, humidity is generally pretty low. Okay, so 30-40%, which means that there's a lot of water that the atmosphere can hold. Whereas when we're here in the Midwest, we'll have days where it gets 80, 90, 95%. What that means is it's very difficult for evaporation to occur, which means you're not going to cool yourself off. And because it's not the sweat that cools you off, but the evaporation of sweat that cools you off, this becomes a problem for a variety of reasons. One, you'll sweat more to try and cool yourself off, but the sweat's not doing a whole lot because it's not evaporating, or it's not evaporating as efficiently. Okay. I remember when I lived in Arizona, I lived in Phoenix for a few years, and I remember that we'd play basketball all day, every day, and it was hot in the summer, but I remember thinking that I didn't sweat very much out there. And the issue was I was sweating plenty, but it was just evaporating so quickly because it was so hot and the air is so dry out there. So some more thermal terminology here is as follows. So just a reminder, temperature is just how hot or cold something is. It's that average kinetic energy. And then we've got, when it comes to temperature regulation, we think of our core temperature being 37 degrees Celsius, so about 98.6 Fahrenheit. Human body can survive temperatures between 35 and 41 degrees Celsius. But there are times actually where when you exercise, your core temperature can get extremely hot, and so your temperature is above 42 degrees Celsius. That doesn't happen very often, and as long as you're not that high in temperature for very long, you'll be able to, you'll be fine. Okay, and so core temperature is regulated through the hypothalamus. Our temperature is regulated in a pretty tight range, right? We try and stay 37 to 37.5, give or take. But as I said a few lectures ago, it can actually get as low as 34-ish without causing too many problems. It can get as high, like I said, as 40, 41, somewhere in there where it's not too big of a problem. Obviously, the longer you are kind of on that extreme range, that's where some bad things can happen that we'll talk about later on in this unit. Hypothalamus is the part of the brain that controls this, but in order to do its job, it needs to get information. And so it gets information from thermoreceptors that are found in the skin, in the central nervous system. You actually have temperature receptors in your brain, among other places. So in the way that this works, we're just going to talk a little bit about it now. We'll talk more about it with the next day's lectures. But here we've got a sweat gland, and so notice that this sweat gland, it's a bunch of blood vessels and stuff that are kind of just tightened in here or tightly bound. They release water, and this water is coming from your plasma, okay? And then it goes up to the surface. So the way that this works is we have to dilate those skin arterioles so they can increase blood flow and lose heat. And then these sweat glands are activated when temperature is high enough. Okay, so they've got some threshold when core temperature, or their temperature, gets above a certain point. They start to release sweat. The hotter it is, the more sweat that is released. Another way we can maintain temperature is just skeletal muscle, right? So when it gets really cold, which we also experience out here in Terre Haute, we cause shivering. So this can cause some issues as well, or not cause some issues, but this helps us to maintain temperature. And then when we get cold, we can also release hormones such as thyroid hormone, and that actually increases our metabolic rate. And then when we increase our metabolic rate, that can increase our temperature as well. So there's several different ways that we can maintain our body temperature, or if it's too hot, we can decrease our temperature. If it's too cold, we can increase our temperature.